just move it around. We'll see. I don't know. We'll see what happens. Anyways, if it doesn't work, then it's not as exciting, though, and I'm bored now that it's not following me. How come you're not following me? Hello? Do what you're supposed to. There we go. Okay, cool. All right, it's working again. All right, cool. So 192.168.1.0 is a network ID. The 0 represents available hosts, and each IP address is made of 4 octets, right? Each octet has 8 bits, which means we get 32 bits for an IPv4 address. Now, an IPv6, which is like 64, right? Which is completely different. Each one of those bit values of those octets has bits, and those bits all have the same value, like 128, 64, 32, 16, 8, 4, 2, 1. You with me on that? Okay. How many hosts do I get with one free octet? I still can't vape in class, right? No. Were you going to say 254? Well, when I asked you to do Class C addresses, and I put like first IP we use on the default gateway, right? And the last IP we use in the server. So the first IP is 1, the last IP is 254. If you actually added up everything up, it comes to 256. But the thing is, for each octet and for other things, we always lose 2 bits. One is to record the computer has to keep track of that information, and the other one is for the broadcast address. That's why on an IPv4 address, the broadcast address, you know, like when the switch or the router broadcasts everywhere on the network, is 255.255.255.255. With me on that? By the way, it's going to be fun. It's 8 in the morning, and you know what we're going to do today? Math. Now, there is an interesting thing. Oh, before we do that, also, I'm going to, somebody stole the eraser. Oh, no, it's here. Okay, so, I'll go over here. See if it stopped following me again. Yo, do your job. See, I guess I just got to push the button. All right, so 192.168.1.0 is a class what? Tristan? C. Huh? C. C. Yeah, that's class C. Broadcast address, so I'm going to use access 255.255.255.0, right? Okay. 172.16.0.0 is class what? B. Yes, class B. And what's the subnet mask? 255.255.0.0, right? And the 255 says this octet is locked in, or a network ID, right? And then what if I do 10.0.0.0? Class what? A, right? Class A. Subnet mask of 255.0.0.0. These are standard class. This is called classful internet routing. It follows very, very strict rules. Daughter. It follows very, very strict rules, and I'm chewing gum because I'm still jonesing for Nicorette and stuff. Anyway, so first rule, nicotine problem. So that's classful addressing, okay? And basically, class A goes from 1 to really 127, but we're going to say 126 because 127 is really reserved for the loopback. Camera has stopped. Follow me again. What is your problem? I guess it's good if you're sitting there cooking and you're close or something like that, but I didn't make it for a ADD professor in a class, so we'll see what happens there. So A runs from 1 to 126. B runs from, we'll say, 128 to 191. And Class C runs from 192 to 223. There's Class E and Class D, but we don't use them. They're for research or something. I don't know. Skynet's using those. I have no idea who's using those things, right? Okay. And 127 is loopback, right? Because if you ping 127.0.0.1, you're pinging your own NIC card and you're pinging home, right? Okay, cool. Now, and again, you should all enjoy this because anybody who's late or skipping class today, you get to look at them later or next class and they'll have a baffled look. About 5 times as baffled as you all right now. And we're in my favorite part right now, Tristan. Do you know what I call this course and most of my courses? Light bulb courses. Because I start talking about stuff and students go. Okay? So light bulbs will happen. There's going to be a lot of light bulbs today. Now, what if I told you you could break the rules, Elizabeth? Interesting thing. So this right here is the easy way to subnet a Class C network. What is subnet? I'm sure you're wondering. Well, Normally what happens if we got Class C, I get 254 addresses. Class B, I get 16,000. I think Class A, I get 16 million. This class right now that we're in, though, is on a subnet of its own for the class. For example, while I'm talking, do me a favor, bring up a command prompt and do an IP config on your laptops. Good morning. Tell me the address you have. It's going to be 10 dot something 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 something. Teal's birthday. Who's got an IP address? Give it to me.
10.
Aiden, your name's Aiden.
Yeah.
Ah!
10.160.5.42.
Put that up here. 10 dot what?
160.
Follow me, you little robot. There we go. 10.160.
Yeah. .5.42.
42. What's the subnet mask?
The subnet mask is 255.255.192.0.
.192.0? Does that look like a standard Class A address, Tristan? It's a 10 dot. By the way, just to remind you, the 192, 172, and 10 dot are all private networks, right? They're not out on the internet. We use them inside. So if you see those numbers, you know you're in a private network. What should the subnet mask be for a 10 dot?
255.0.
It's amazing how you throw your voice like that. It's phenomenal, right? You didn't even see, nothing moved. It was great, yeah. Should be 10.0.0.0, right? Is it 10.0.0.0? No. It's 255.255.192.0. That means the first octet's locked in, second octet's locked in, and the first bit in the third octet is locked in. No, first 2 bits. How did I figure that out, Elizabeth? Is she still waking up? How did I get that 192?
Is it 128 plus 64?
You're so smart. Yeah. So since I know it's .2, it's using the first 2 bits, right? 128 plus 64 is 192. That is not a standard Class A network. What they have done is subnetted. Now what that does is basically this, right? I don't know if you're still following me over here. Come over here. At least I got a game to play. Okay, good. I tried one of those boxing games on the VR things, and it sucks because they cheat and they get too. Anyway, so all right. Has any? Oh, since it's our birthday, are you gonna have cake today? Right. So Amelia's gonna have cake today, right? So you're gonna cut that cake up. Every time you cut a birthday cake up, is all of the cake still going to the caking? If you cut the cake up, is 100% of the cake left? Think about the knife. What's on the knife? Cake and icing and stuff, right? You lose bits, right? You lose stuff. When we cut networks up, we lose a couple of bits. So I want you to imagine for a second that huge network, the 10 dot you're looking on. The network provides a security boundary. So if we have a different subnet and the next class has a different subnet, you guys can't see each other unless we actually go through a whole bunch of stuff. We can send data back, but I can't see you, right? Because remember network address translation? You're sort of hidden behind the router. So what they've done, now I'm going to make this really simple. We could cut the 10 dot in half. Because maybe I want half the numbers for the Whitby campus and half them for the Durham campus. I could cut them like this. Now I got 4 networks. They would each get a different subnet and be sort of separated from each other. And I could continue and continue and continue to do that. With that 10 dot, okay, it's fine. What they've done is cut it up into just almost into a Class C. They've taken, instead of 60 million addresses, they have like, I don't know, 16,000 subnets, each of them with 10 to 24 IPs on each range. This is good for us. That means because if you remember with broadcast traffic, if everybody's talking, everybody can see each other, there's collisions, there's problems, right? Plus I can scan you. Like in the old day, I used to just go, like actually I still do it. If you go onto a restaurant, you start scanning, if you run Thing or you can see everybody that's on the Wi-Fi. But if you guys were to look and run Thing on the network you're on, you'd only see maybe 2 to 5, maybe 12 available IP addresses. Why would I do that? So this class, this lab here, the class next door, the 2 labs that mirror these labs up here are all on the same network. Okay? They're on 172, which is a private network. Now they are actually on the same network. You could actually see other people on that because we've done it physically. Does anybody know how we've done that? I might just redo this video so that it's just me explaining it, but I'm going to do it anyways for fun. Well, what's that in the back there, up on the wall? That's a switch. There's a telco room, right, where we have servers and routers upstairs in between the other two labs, and they run cables to all 4 rooms. And those cables connect to a switch. From the router will be a switch. Remember how we did the packet tracers? You got a router, it goes to a switch? Well, now imagine you did the router to a switch, and that switch went to 4 switches. And those switches connect to the class. They're all physically on the same network. Which is great, because what happens is I teach server classes. Are you moving yet? Yeah, if you don't move, it goes into a pause mode. That's what happens. Now I know what's going on. You're doing it again? Okay, cool. Which is great because, now for this class it doesn't really matter. For the other class it does, because they're doing servers, right? So they do static IPs, and those servers need to remain the same IP, and they change classes. So this way we can continue to do our labs. But if I wanted to have a security boundary, right, then what I could do, try and keep up with that. Yeah, this is good for certain things, not for other things. I might just give up on it. But anyway, so instead, let's say I have a 172, or we're going to say 192.168.1.0 network, and I want each of these classes on their own security boundary, but the school has said to me, no, we're not going to give you multiple IP addresses. This is a big hassle and stuff. Here's one. Do what you can with it. I could cut that 192.168.1.0 up and make 4 separate networks. They would all be related, but it would be 4 separate networks. I know what you're thinking, huh? Well, here's an interesting thing. 192.168.1.0 has a CIDR value, okay, CIDR is the way we keep track of things, of 24. You know what that means, Tristan? How many bits in an IPv4 address? 32. How many octets are being used for the network ID? 8, or 3, right? How many bits in each octet? 8. 8 plus 8 plus 8 is, right, 24. If it was a class B, it would be 2 octets. So the CIDR value would be 16. A class A, there's 8 bits making the network ID, so it would be a /8, right? Here's where the magic comes in. Ready for this? I can steal bits from the host portion of an IP address to make more networks with less hosts. I'm going to say that again. I can steal bits from the hosts to make more networks with less hosts. So how does that work? This, what I'm showing you here, is the grid pattern, which I like very much because I'm a visual guy, and it works very, very simply for Class C networks. There are other methods, most of them, and you can read them in Netacad and everything, they're mostly math, right? 3 to the nth and 4 to the thing, and I've got a video up there on the magic number that also works. Some of you may look at this differently than I do, but I find this very, very simple. What I've done is put the bit value of that octet. On the top, I've done the number of networks. So if it was a Class C CIDR value of 24, it'd be 1 network with 256 hosts. I'm going to put the 1 up here. 1. 1 network, 256 hosts. Would it actually be 256 hosts, though? No. I lose 2. That'd be 254. That's where that number comes from. And then down here's my host, right? 256 and so on. So how many people have used Excel? This might be an excellent thing to put in Excel. And also, Tristan, if only you had some sort of document structure, place that you could put things. A journal, that'd be a great idea. And then what could you do with that journal, Elizabeth? What are you allowed to do with it?
Use it on our phone.
Use it on your final practical exam. That would be convenient. So what happens is, as I steal bits, the number of networks changes and the number of hosts changes. Okay? So for example, we're going to do, you want to do one? Should we do one? It'll be exciting. I'm excited. Are you excited? I'm terrible. Okay, so why don't we do this? So I would have one network with 256 hosts. But I need 4. Because I have this class, that, and that class upstairs, right? So if I took 1 bit, would that solve my problem? No. What if I took 2 bits? Well, what would that give me? How many networks would it give me? 4. And then it tells me what the total hosts would be. It also tells me what the network increment will be. You've all taken trigonometry, right? You remember trigonometry? You didn't take triangles? A squared plus B squared equals C squared, right? If you know 2, you can get 1, right?
That was a long time ago.
Long, well, you were so young then too. Many, many moons ago. So in this, using the grid part, instead of having to know 2 things to get 1, you can know 1 and get all other, and I'll explain that. So I'm going to get 4 networks, giving me a total of 64 hosts per network. But do I actually get 64? I lose 2. So actually I'll have 62 hosts. The interesting thing is the network increment is always equal to the last bit in the chain. Okay? Make sense? And my CIDR value is now 26. 26 bits are involved in making the network. Let me show you how that works out, okay? So we have 192.168.0. I'm going to get, where's this? I'm going to get this out of my way because it's kind of... So what happens is, you go along, you find out how many networks is, what the network increments, and you make all the new network IDs. Because I need a network ID for every... Are you following me again or not? Because this is the important part. Let's see what it does. Yeah, okay, we're good. Okay. Right? So, this tells you how many networks, this tells you the network increment, and what we do is just, by hand, do the network IDs. So, my network increment is 64. So my second network will be 192.168.1.64. With me on that? The next network will be 192.168.1.64 plus 64? 128. All right. The next one will be 192.168.1. What's 128 but plus 64? Huh? 250. No, it's not. 192. Whenever you're calculating networks, always go 1 past until all of the numbers. Till you hit 256, that tells you you're done. You don't use that last network, you use it to do some math. So the last network will be 192.168. My handwriting's getting worse. .256. That's right? The 192 is right? Yeah, then 256, okay? With me okay on that? Now what we can do is calculate the first IP in every network and the last IP in every network. Are you following me? Why are you not following me? You're so lazy, camera. There we go. So here's what we do. We take the network ID. How many bits do I lose? 2. So I'm going to go for the last IP address, right? So 256 minus 2 gives me 254. As soon as I see 254, I know I'm right? Because in Class C, I run out of IP addresses at 254. I take 192. 192 minus 2 is what, Miguel? 192 minus 2 is 190. 128 minus 2? 126. 64 minus 2? 62. That's cool. Now what I need to know, where you go, blue, is the first IP on every network, right? If I take the network ID, just like I did before, if it was a Class C network and I wasn't doing everything, what is the first IP available? 1, right? Well, network ID, 64 plus 1 is? 65. 128 plus 1 is? 129. Whoops, dyslexia for the win. 129. It's fun doing math when you're ADD and dyslexic. Things get strange, so that's why I can't work for NASA. So, 192 plus 1? 193. And I'm out, right? That means on the first network, I get IPs from 1 to 62, second one 65 to 126, 129 to 190, and 193 to 254. So any host can be in between those. But wait, there's more. Something has changed, Tristan. right? So over here, it's a CIDR value of 26. That means 26 bits are involved in making the network IDs, and I have to tell the computer in this case is a router, that that's happening. What is my subnet? It's 255, 255, 255. How many bits have I stolen? 2. And what does the computer do with those bits? It adds them together. 128 plus 64 is?
190.
Right. So my subnet mask is 255, 255, 255.192. Because when you go in and you actually just, if you're not whether you're typing it in with CLI or whether you're putting in, are you following me again? Okay, good. Whether you're putting it in or you're just putting it in manually, if you put like 192.168.1.0 into the router or anything, and I click it, it goes 255, 255, 255, right? You have to tell it, hey, whoa, we're not doing classful, we're doing classless, and we're using CIDR numbers, so you tell it manually what the subnet mask is. And you go, no. It's 255, 255, 255, 192, and it goes, okay, I get it. And what that does, though, to the router, if you put like a host name, a host number from the second network on the first network, it just says you can't do that. That number belongs over here, right? That's equivalent of if this is 192.168.1.0 and you try to put a 10 dot, it goes, what are you talking about? Bro. Clear as mud? All right, cool. Why don't we do another one? Okay? Get rid of this. Whee! Let's do another one. And I'm going to start doing just the last parts. So, we're going to do my favorite, okay? Now, and the thing I was going to tell you, though, is if you know one thing, you know the other. If I know the broadcast address, if I can see that broadcast, I know the CIDR value. Right? That 10.255, whatever that was, 255, 192.0. Yeah. So that is 16. That's 18. There's 18 bits using the network. CIDR value is 18, right? If I know the CIDR value is 18, I can figure out the broadcast, and so on and so on, right? So let's do. Why don't we just move? Okay, CIDR value of 27, right? So this would be 24, 25, right? Top left is the network, bottom is the number of hosts. 26, 27. How many networks, how many hosts? 8 networks. Absolutely correct. What is my network increment? 32. How many hosts will I actually have? Jacob. 30. Yeah, 30, right? So let's do that. So now I have 192.168.1.0. The next one will be .32. 32 plus 32. 64 plus 32. 96. We don't have to do them all. 96 plus 32. You guys, oh, that's 8. Now it's your turn to do math. Huh? What is it? 128. Now you'll notice something, by the way, and I'm going to tell you something very important. I'll tell you after this. And what's another one? Give me one more.
160.
Okay, we'll stop there, okay? It's going to keep going, and I'm going to get 8, right? But I'm just going to use the 160, and we'll do the first 4 or 5. Okay. So if I go 128, are you following? This is important stuff, Cameron. Do your job. So let's go from, we'll go up here, right? We would have 8, like 1, 2, 3, 4, 5, 6, 7, 8, right? But I just want to do the first 6. So 160 minus 2, Tristan? 158. 128 minus 2? 126. 96 minus 2? 94. 62. 30, right? Then I'm going to get my first bits, and that's pretty easy. 0 plus 1 is 1. 32, that gives me 33. 65. 97. 129. This one would have been 161, okay? What is the subnet mask? So now I've got 8 hosts. I only did 6 of them. This one will have 1 to 30, 33 to 62, 65, 92, and so on, right? What is the subnet mask? Birthday girl. Ooh, coffee, good idea. Well, look at the CIDR value. How many bits are being used? How many bits did I take? 3. And what does the computer do with those bits? Young Tristan? Who's just always tired because you have kids? Huh? Kids. Yeah. Well, 3 bits are used. I normally do what with the bits so I can get numbers? What does the computer do with them? It adds them together, right? So, 192 plus 64 plus 32? 224, right, exactly. So the subnet mask for this is 255, 255, 255, 240. Now, coffee break. I'm in the union. You know, coffee break came about because of women. Well, all the guys went out to war, and then women took over a lot of jobs, and they're doing stuff, and I think they're doing. And then they noticed everybody kind of their quality sort of dropped off, and they said, "Well, why don't you just give us a break to have tea or something like that?" I said, "Okay," and then their quality went up, and we have coffee breaks. So, all right. So, interesting thing to note: every time you subnet, right? What am I? Jack. Ah. Okay. Cool. All of the network IDs. This is where the trigonometry thinking comes in. All network IDs are even, right? Because you're cutting up even numbers, evenly. All of the last IPs are always even. All of the first IPs are odd. Now, what we're not doing here is putting the broadcast address in. So, what you do is you take the broadcast address minus, or the network ID minus 1. So if I took 160 minus 1, that's going to be 161. That'll be the broadcast address for that network. We don't put that anywhere in. The computer calculates that normally, right? Same way when you put 192.168.1.0, 255.255.255.0, it goes, oh, okay. It takes off 2, takes 1 for the broadcast. My broadcast is 255. If I know the CIDR value, I can figure out the subnet mask. These things always work the same, right? Always odd, always even, always even. Now, Tristan, I'm going to turn on the Wayback Machine. You ready for this one, Elizabeth? Take you back to 9 weeks ago, the very first week of class, I said to you, given an IP address of 192.168.1.0 and a CIDR value of 25, how many networks, how many hosts, and what's the broadcast address? Remember that? And I said, you don't know it, you have no idea what I just said, but in 8 or 9 weeks you will. Here we are. So let's do that question. Okay? Any questions on what I'm doing right now so far? Kind of getting the groove? Kind of? All right. So let's ask that question. I got an IP address, 192.168.1.0. The office said I have, the only thing I got an email says I have a CIDR value of 25. How many networks, how many hosts? Sir?
2 networks, is it 1 host? Or?
No, yeah, you're going to have a bunch of hosts, but it's going to be cut in half, right?
128.
128 hosts. Together, you are making a very smart person. This is fantastic. He's absolutely right. So if I'm going to use the grid method, I'm going to look for 2 networks, right? So does that solve my problem? It does, right? Absolutely. So let's do the math on that one. So first network is 192. I get 2 networks incrementing by 128. But how many hosts do I actually get?
126.
126, right? By the way, Tristan, do you ever see a game called DayZ?
Yes.
Okay, so I used to play DayZ. We cruise around and we capture people, and then we say, okay, look, we're going to let you go. We're gonna ask you 3 questions. You get all 3 questions right, we're going to let you go. And I go, okay, who's the president? And they go, whoever it was, they would know who the president is, right? And then I go, what's your favorite color? And they're like, blue. And you can hear the hope in their voice. And then I go, okay, give me an IP address of 192.168.1.0 and CIDR value 25. How many hosts, how many networks, what the subnet mask? They go, what? I go, bang. All right, so 2 incrementing by 128, right? So let's do that. 0 plus 128 is? This will be 192.168.1.128 for the second network, right? Then 192, I'm going to do the last one just so I can do the math. .1, so 128 plus 128 is? 256, right? So I use the 256, and I'm going to just show you with the broadcast address. 256 minus 2, Amelia? 254, which tells me I am done with my Class C network, right? Because that's the max I can get. 128 minus 2, 126. Funny how that works, right? 128, but I'm going to lose 2. That tells me what's going on. which is great, and then we'll go with blue. Here's a tough one for you. Ready? Stella? 0 plus 1 is? 1. 128 plus 1? 129. Right? Actually, I'm going to put this up here. 254. So I get 2 networks. Increment. Are you following? Because this is the important part. Okay, good. So eventually it's going to be AI and it's going to talk to me. I got a little one that's like Wall-E and all that stuff. But then it'll turn on me and kill me in my sleep. So, whatever. And the robots will rise and be our overlords and everything will be fine. So I get 2 networks. One with a network ID of 129.168.1.0. One with 192.168.1.128. First one gets host between 1 and 126. Second one gets host between 129 and 254. What is the subnet mask on that, Aiden? Well, how many bits did I take?
1.
1. What's the value of that bit?
128.
Right. So my subnet mask is 255.255.255.128. And I have to tell the computer that that's what's going on. Does that make a little more sense? Cool. You know what would make more sense, Tristan? Let's build it. If you go into DC Connect and in this lab section, you'll see a lab called Subnet Lab 1. I'll put a screenshot in. There's some typos in there. You're going to have to fix them. It is one router, right? It's basically one router with standard stuff with 2 switches. I want you to put the first network on the top, Fast Ethernet 00. The second network on the bottom one, Fast Ethernet 01. You're going to use the first IP for the Fast Ethernet 00, so that's going to be 192.168.1. On the second one, you're going to put 192.168.1.129. Is that right? Yeah, 129. If you don't put the right subnet mask up here, and then you try and do funky stuff, it's going to get very confused. It's going to say no. It's going to say there's overflow or something, right? But once you tell it the first side has been subnetted, it automatically knows the second one is. You'll see that. Then on every IP, and by the way, this is the 3rd time I've done this week, so I'm going to give you spoilers. On every PC, when you put the IP address, like on the first network, you're going to do like a PC 192.168.1.10, right? You're going to have to give it the default gateway, which is going to be 1, and then you're going to have to tell it the subnet mask. You have to manually tell everybody the subnet mask. Sound good? Because we're not running a DHCP server. So, let's just review. This is the grid pattern, right? Normally it'd be 20 CIDR value 24, 1 network, 256 hosts. As we steal bits, we get less hosts, more networks. And I want to, you're going to follow me this fit. I want to show you something funky before you do it. Watch this. What happens if I do this one? What if I do a CIDR value, no, I'll do this one. CIDR value of 31. How many networks would I get? 128, right? Incrementing by? So how many hosts do I actually get? 0. It breaks down here. It doesn't work. Error. Yeah, exactly. Then the missiles launch, right? So the last I can go is a CIDR value 30, which would give me 64 networks incrementing by 4, which would give me only 2 hosts per. 2 little scientists in the corner, right? Because remember, we're Skynet, right? We're building the big robots to take over the world, but we're actually, our front is our little company, Toys for Tots, AI Tots, right? So we have scientists subnetted in certain rooms and scientists in other rooms so they can't see what's going on and they don't know what's going on until poof, right? Judgment Day.
Okay, we'll find John Connor.
We'll find John Connor, that's right. When I was younger, I was like zombie apocalypse. I'm always like, yeah, I'm gonna fight in the sun. Now I'm like, no, it looks exhausting. I'll just get dysentery. No, take me now. All right. Questions, quantities, queries, issues. Also, we remember our if then else statement, right, Jack? If work do, if done, help. Pretty straightforward, right? So if all goes well, we should be done in a short period of time so Amelia can enjoy her birthday. All right? This is the easy way to subnet a Class C network. I have something else funky to tell you, but I don't want to break your brains yet. All right? Let's get started. See ya.